Okay folks, as you know, I'm not here today. You guys have just finished up the quiz. Hope you did well on it. Now we're going back to inclined planes. So these are setups. We're going to do the setups, and what I want you to do is get it all the way through to acceleration. Even though it says just to get it to the F-net equation, let's go the whole way. So for the first one, what I want you guys to do is to set up the free body diagram. So what's going to happen is I'm going to do a little bit of instruction. You guys are then going to work on it, and then we're going to pause the video and then come back to it. So the first thing you guys are going to do is we're going to put the object on, and then I want you guys to do the free body diagram. So we're going to take a few seconds right now and have you guys do that. So if the sub could go, turn it off right now, and then turn it back on in a couple minutes when people are ready. Okay, so hopefully what you guys have is this. The very, very first thing you put in, first vector, is weight. There's your weight, which is mg, fg. And as you know, I like to go and calculate this out really quickly. So I sit there and go, all right, this is 9 kilograms, negative 9.8 meters per second squared. I'm going to dash over here for a second. I dashed back. So I'm going to do this. So it's going to be 9 times 9.8, and we get 88.2 newtons negative. Remember, the second vector you want to put in is the normal force. That's going to set your other guys. So the normal force comes off perpendicular, and that's why this is the normal, which is also equal to the force perpendicular. With that then, I know that it's not moving in this direction, so I can put my force perpendicular this way. And you want to be a little bit artistic, make that perpendicular. You want to be a little bit artistic in that you want to have this guy, this vector, being parallel to the ramp, which means, of course, it's going to be force parallel. To finish things off, we have a force parallel, which is there, which finishes off the rectangle. And then we also have a frictional force. And we know that we have a frictional force, 0.3. Okay? So, with that being said, now you want to go and you want to set the F-net equation and then find the F parallel and the F perpendicular based off of the weight. So, the sub is going to turn it off for a second, and what I want you guys to do is you guys are now going to go do the F-net equation in this parallel direction, and then find the F parallel, and the F perpendicular. Okay, so if the sub could turn it off for a second, and then we'll get started in just a few minutes. All right, now we're back. Let's see if we got this correct. F-net, and this is parallel, is MA parallel, because all net forces, second law, MA, and they go parallel. What do you have? Well, we've got the F parallel plus the frictional force. And it's going to go in a negative direction because it's going away from the motion. Now I've got to figure out what these guys are. Remember, the F parallel, right, and the F perpendicular are components of the weight. So I'm going to go F parallel, F perpendicular. This is where it's a little bit tricky. Remember, this angle, which is there, which is a 33-degree angle, is the same angle right there. So that means for the F parallel, it's opposite, so it's going to be sine. And the F perpendicular is adjacent, so it's going to be the cosine. So you go, great. That means it's going to be weight, in this case, sine of theta, and this is going to be weight cosine of theta. Let's work it out. 88.2 newtons, sine of 33, and 88.2 newtons, cosine of 33. Because remember, it's the components of the weight. Then you guys should have 88.2 sine of 33. You should get, check something here real quick. La, 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 la. Okay, we're fine. So we're going to go 88.2, the sine of 33, and we should get 48 newtons. And this should be 88.2 cosine 33 and 74. Those are what you should have. Now we're just going to work linearly to get to the answer. Remember, we want to find the acceleration. So, mass, 9 kilograms. And we're doing the F net. 9 kilograms times the acceleration equals F parallel, which is 48 newtons, plus, well, we now need to do the frictional force. The frictional force, this guy here, is equal to mu Fn. And remember, the Fn is the F perpendicular. So it is going to be the 0.3 times the 74. So, times 0.3, and we get 22 newtons. And it's in the negative direction, so we're going to put a negative there. So, I'm going to go negative 22 newtons, because that's my frictional force. And I'm going to get here, this is going to be 26 newtons, is 9 kilograms, times the acceleration. Final step, just divide. So I go 26 divided by 9, and we get acceleration parallel, 2.9 meters per second squared. A lot of crap, I realize that. So let's take a step back, take a look again. Here is your free body diagram. Do your weight first. Then you do your normal. Then you're going to have, with this, the F perpendicular here, F parallel there, frictional force there. You figure out your weight, realizing that the F parallel is opposite, the F perpendicular is adjacent. You can figure out your sine and your cosine. You work that out and you get those values. You then set it back in the F net equation, and so you get mass times acceleration, parallel, frictional force, and you work it out. So far so good? Awesome. We're now going to take a couple seconds for you guys to take a look at it, ask each other any questions and that sort of stuff. So, why don't you guys do that just for a second, and then we'll come back. Well, welcome back. Hope things are going well. I'd like to thank Carter, who's doing my filming for me today while he texts. We'll be giving him a detention later. Okay, moving on. So, are you actually texting, Carter?
No.
No, okay, yeah. He's sending illegal emails. Okay, fine. So, what we've got here is, we have this guy. We're going to do the same exact thing. First thing you're going to do, free body diagram. Sub, turn it off just for a second. We'll get to it. All right, welcome back. Oh, by the way, found out Carter was not texting. He's actually ordering pizza. So anyone who wants pizza, just tell him what you want. He'll order it for you. Thank you. All right, so we have a 12 kilogram, which is right here. First force we always put in, weight. Now, the reason I did this guy in this direction is because the ramp could be going either way, okay? But it's still the same process. So, weight is mg, fg is 12 kilograms. Negative 9.8 meters per second squared. So we're going to go 12 times the 9.8, and we're going to get 118 newtons, negative. Remember, the second one we put in, the normal. And it is going to be perpendicular, so it's going to be coming, here's that surface, so it's going to be straight off of that, and it's going to be going basically this way. Whoop. So that, a little bit smaller. There is your normal, which is your F perpendicular. This now allows us to get this guy. Remember, it's going to come straight this way. And you want to draw it in such a way so you can get this guy to be parallel down. So I'm going to make it just a little bit longer, and we're going to get that guy there. So now we have the F perpendicular and the F parallel. Remember, the F parallel was going down this way, and you have your frictional force going that way. Now, what I want you guys to do, find the net equation, and then go and figure out, so you're going to do the F net, and I want you to do the F parallel and the F perpendicular. So, really quickly, we're going to take a little break. You guys come back just a second. All right, welcome back. Oh, by the way, Carter could not get the pizza. Turns out they would not take his name as being Carter. Okay, now, so with this, we're going to do the F net first. We realize it's going to be mass times acceleration in the parallel. And so therefore, the two things we have in the parallel is the force parallel and the force frictional, which is like that. Awesome. Now we're going to do the F parallel. Now remember, this is going to be the sine. So it's going to be the weight sine theta, and this is going to be the weight cosine theta. Always have your equations, folks. So 118 newtons sine theta, 118 newtons cosine theta. When we go and we do that, we're going to find 118 sine theta, which is, in this case, we have it being 50 degrees. So I'm going to make this 50. And that guy 50. And you guys should already have this. Sine of 50. 90 newtons. I'm just sort of going to whole numbers. 118 cosine 50. We get 76. Okay. Now, I want you guys to work this through to get the acceleration. We'll just do a little pause, and we'll come right back. And then we'll be done. All right, welcome back. I just wanted to mention to you, I'm changing my name officially from Thomas Motroni to Henry Motroni. Okay, tired of the Thomas. I'm going Henry. Okay, all right, moving on. So now what we've got here is this. We're going to the F net. Mass times acceleration in the parallel. F parallel plus the frictional force. Boom. Plug in what we got. 12 kilograms. Acceleration. F parallel, 90 newtons, plus the frictional force. Now, we don't have the frictional force right now. We've got to get it. But if you guys remember, what are we? We're physics rappers. Why? Because we break it down, okay? Speaking of rappers, Carter's going to be coming out with his next rap album called the IT Blues. Okay, so with this, now what we do is this. We say, hey, frictional force, that's mu Fn. Okay, not a problem, because we got the 0.2 times the normal, which is the perpendicular, 76 newtons. Okay, so we go 0.2 times 76, and we get 15. Now we put that in here, 12 kilograms. Acceleration parallel, 90 newtons, plus here, the negative 15 newtons. So we go, okay, 12 kilograms times the acceleration equals 75 newtons. And now we're going to go 12 divided by the 75, and so therefore, I'm sorry, 75 divided by the 12, oopsie, 75 divided by the 12, and we get 6.25. So the acceleration, we'll call it 6.3 meters per second squared. Practice is what's going to make this happen, people. You got 2 more in the back. Make sure they're so done for the homework. I will see you guys next week. Have a good one. Thank you very much. Thank you, Carter.